race against time as far as the corn goes. And one problem we have is our, oh, look at it, it broke right through it broke through it, look. So, let's liberate the baby. Okay, there we go. Okay, nonetheless, both of these look equally healthy. Notice this? Even though this has got no chloroplast at all. I just love this corn. Now, the reason why it's able to survive and look so healthy is it's getting all its food from the endosperm in the corn kernel. And then what happens is it eventually will die and droop and not be able to survive because it can't do photosynthesis. This will keep growing. Now you can see you've got a bunch of fungus, but let me see if I can see some root hairs on here. Okay, oh, very pretty. Okay, now what it amounts to is the ones that are longer here are actually lateral roots. This is considered a fibrous root plant because you see how many roots are coming directly off the stem, whereas in most dicots they send one big taproot down, and the taproot has a lot of lateral roots to it. Now in addition to that, there should be root hairs. You can kind of see right in here. You see the little tiny hairline. It's great. It's cool to look at this under the dissecting scope, by the way. But those are lateral roots, but each lateral root has got a little bit of, it's just the finest little tiny hairs. Those are actually root hairs. You're actually seeing part of the plasma membrane there. It's that fine. It's actually part of the epidermis sending out part of its plasma membrane is what it is, to absorb more materials. So, now, one problem is you don't have a dicot in here. Your dicot did not make it. Or may not have even germinated as well. Where's your dicot? Did you guys have good dicots? You did, didn't you? Would you mind if we borrow it? If it is, I'm just going to keep it up here because a lot of people are not getting good dicots. What happened was they turned the air conditioning off in the summer, and we think the seeds got too hot, and so only a small percentage of them were germinating, and you just got the luck of the draw where yours was not a healthy seed from that because of the age of it. So
both of those are monocots?
Both is monocots, and it's this is a special albino corn that we're growing to show you. And my suggestion is, why don't you guys keep growing it and let it stick out the top like this. Maybe take another container for water, and let's see what happens to this. Because my prediction is once it runs out of food down here, this is going to completely shrivel up and die. This will keep growing. To a certain extent, if this is not in soil, it's going to be lacking nitrogen and phosphorus. Now, we could actually make up the right solution. We could grow these hydroponically. You can actually grow plants without soil. But I know we're missing a lot of the nutrients. Okay, now, where's your atlas? Does anybody have an atlas with them? Why don't you bring your atlas up? I want to show you what this is in the atlas. Show you how to identify these things.
That's hard for me. I looked it up.
Okie dokie. All right, so what it amounts to is I don't think they have corn in here at all. They don't have the corn diagram whatsoever. Okay, so right here we're going to look at the dicot. Since you guys didn't get dicots, then of course that's unfortunate. So let's look at Team Awesomes. They were lucky enough in terms of what they got.
So, do the monocots have the taproot or the dicots only?
Dicots have the taproots. Most monocots send out fibrous roots. And if you think about it, whenever you have weeds growing in your garden and you try to yank them up and only part of it comes up, those are fibrous roots.
Oh.
You can tell. You know, it leaves a large part of the plant behind it. Those are fibrous roots from that. Dandelions have taproots, so when you pull those up, they have one big long root. Of course, the problem with those is that if you break it off or the taproot's still down there, it'll send up another shoot as well. That's what we call them weeds. Okay, here are two of the dicots, and one way you can tell is, you see the two foliage leaves? What's it called?
They're like netted.
They're netted, exactly. There's two. Dicot. That's the reason. So the first leaves that come out are dicot, whereas this only send up one cotopile, right? So it is a monocot.
Those are compound?
Let me just see. No, these are not. These are pinnately. These are not palmetly. Palmetly would be started here and then radiate out, whereas you can see there's a center vein that comes off of that as well. Okay, now, this won't be here probably next time we look at these. This is Tung did this. He knocked off his cotopile, his cotyledon. Cotyledon was right there, and let's see where it is. There it is, he knocked it off. I say that. It is right here. That was the cotyledon. Right here, the plant came out later. It germinates later. You can see it's much thicker. And of course, when it first swelled up, you can see the size of it here. It's even larger. Now, again, the endosperm is where the food is first formed when you have that double fertilization. The purpose of the tissue is to make lots of food for the seed. So in the corn, it's all endosperm. When you pop corn, you're eating endosperm. As I told one group kind of jokingly, he said, next time you pop popcorn, serve it and tell your friends that you're having endosperm for snacks and see what the response is. We have a rule in my family. My mother will not allow us to speak sciences at the dinner table. You're not allowed to say pass the sodium chloride because she doesn't know that's sugar or table salt. She can't tell. So she finally passed a rule that we couldn't ask to pass the cotypiles or the cotyledons or anything. So for lima beans, we said, please pass the cotyledons. We used to do that all the time. Okay, so that's a rule in my family. I don't know about yours. Now, between here and here is the epicotyl. Now look right here. See that little place right there from the cotyledon to the top is the epicotyl. All of this is the hypocotyl. And you see how it was bent? I'm kind of bending it more. I'm mutilating your plant. I'm sorry. What happened was it broke the surface of the dirt and then sprung out. Whereas the cotopile sent one shoot straight up. So that's monocot cotopile. Okay, and they all sent out a radical first. Both of them have radicals. And what happens is the radical becomes the taproot, whereas on the corn that I just showed you, on the monocot, the first root that comes out is the radical, but it's a fibrous root because then more come off of the stem. Whereas usually on this, the lateral roots tend to come off of the side. You can actually see the lateral roots really well right here. They're all coming off of the taproot. And these are not your best example. The best thing is that if we were to be digging up a tree that has a real deep taproot, like a pine tree, you could really see it. It's the main root that's going down from that. So, if you look at your list, the list of the terms you need to know for the exam, you'll see that all of these are on here. Now, this is when it first germinated right here, and of course you see the radical coming out. And right here, you can see that that's the hypocotyl right here, and there's the cotyledon, so you can't see the epicotyl at this point. You can see it over here after it's gotten to be bigger, and then this falls off because it's used up. This is where it's got all of its extra food. Back to what I was saying, the dicot transfers its food in the seed from the endosperm over the cotyledon, and the endosperm is really vestigial by the time the seeds are moved. But everything starts as the endosperm, whereas the corn stays as endosperm. See all this is endosperm right here? And the cotyledon is only this little tiny layer right here. It's got a cotyledon, but doesn't use it. Whereas this does use its cotyledon. And the lima bean was all cotyledon. You guys stained that, and you saw how the cotyledon was kind of that brown? That's because it's got starch in it. You can tell that that's the main component of that cotyledon. And probably this cotyledon, too, is got starch as well. So, that's all the plants, but if you'd like to, let's go and put theirs back as well. And we kind of lovingly put this on top of it. We're going to see what happens with these. They'll only go to a certain point, though, because they won't have all those nutrients that it needs as well. Okay? We'll put both of those back. Is there anything else?